All right, thanks, Malta. Can everyone hear me okay? Okay, I'll assume that's a yes. All right, well, thank you everyone for coming. I'm pretty excited for the set of papers on robots that we have ahead of us. But to kick things off, I wanted to start with a bit about human-human interaction. And in particular, what I want to focus on is the fact that one of the most firmly established phenomenon in social psychology is this relationship between similarity and liking, and that is that people tend to respond more positively towards people who are similar to themselves, and perceived similarity can, in appearance and behavior, personality, etc., can lead to more positive outcomes such as friendship formation, empathy, and prosociality, for example. And this similarity principle has been applied widely in human-robot interaction, and with a goal of facilitating better interactions between people and robots. These psychological foundations have in part driven the development of what are increasingly anthropomorphic social agents, and to great success. And that is, in this case, human similarity also facilitates liking in human agent and human robot interactions. And in particular, these human-like attributes provide these communication mechanisms with which people are familiar, and that in turn affords more natural and intuitive interactions. And so people have really progressed with this idea, building robots that in their appearance, in their behavior, etc., mimic people. So for example, these can have really positive outcomes. So if we consider this industrial robot, here's more of an iconic example of what you might think of as a robot. And this is not a robot with any human-like characteristics. Rather, its form and its design is based primarily on the functional processes for which it's intended. And so in this case, this robot is intended to locate, grasp, and move objects for the purpose of automating, say, assembly lines. But we have here another instance of an industrial robot, but this one is a human-like industrial robot, so you might be familiar with Baxter. And what we see here is that by moving towards something that's more human-like, so previously we had something that was just one single arm and kind of a pincer mechanism. Here we have two arms and a display screen for a face, and clearly the display screen isn't necessarily functional for the purpose of automation and its tasks of finding, locating, and grabbing objects, but it can have really significant outcomes on how people perceive it. And so as a preview of one of the upcoming talks, in this very critical, safety critical setting, people relate to the robot as a social entity, and in particular, what's very poignant here is that the robot's appearance helped people feel more safe. So if we plot that on kind of the spectrum of human similarity, we have our more iconic industrial robot arm. Here we have the humanoid industrial robot. And if we think of human similarity as being 100% human, we have a human at the end of the spectrum. And we can think about that in terms of affinity, that this principle of liking facilitates or implies that similarity implies liking. We have our robotic arm that has very low similarity and perhaps low affinity, and Baxter achieves quite a bit of an increase in likability. And then the idea is that this continues all the way down the spectrum to obviously humans. And this has motivated the development, in part, the development of more and more human-like or humanoid agents. So for instance, here we have Albert Hubo, who is another instance of a humanoid agent with a very human-like face, human-like hair, but still more of a mechanical body. And we also have, much further along, we have the Geminoid, which is an instance of what's called an android robot. And here, if you can't quite tell, the robot is is on the left, and there's a person on the right, and the person is, the robot is modeled after this person. So as you can see, it has a very human-like appearance in terms of the hands, the hair, the skin, etc. So this is quite down the line in terms of human similarity, but greater similarity can also result in aversion. So we have, instead of this similarity principle applying throughout the whole spectrum, what people have observed is that it doesn't necessarily end up with positive outcomes. And this has been described as the Uncanny Valley hypothesis, which was originally posited nearly 5 decades ago by Masahiro Mori. And how he described it was that with this likability principle, or similarity principle, that he described people will generally respond positively, more positively with increasingly human-like agents. So we have our robotic arm and Baxter, and then let's add in Albert Hubo, the Geminoid, and again our stereotypical human. And so we look at that and we can see the robotic arm fairly low in affinity, Baxter increases a bit, and maybe even Albert Hubo even further up on that spectrum. But what Mori hypothesized is that with things that are, much closer to this end of the spectrum, that instead of affinity, we actually end up with aversion, or the opposite effect than what was intended. And this is what is referred to as the Uncanny Valley. And despite these indications that people can have these really negative responses to such agents, it's received fairly little attention, despite this somewhat boom over the several decades with the development of more and more robots intended for social interactions, such as interactions with people. And moreover, people have really debated the existence of whether or not the Uncanny Valley exists, going so far as to call it a hindrance to the exploration of design for humanoid and social agents, or even a myth. But there are some extreme instances and very real-world instances in which we see this effect can be particularly important. For example, some of you might be familiar with the Sleepwalker statue installation that was at Wellesley College this past year. And what that was a highly realistic statue intended by the artist to depict a man who is hopelessly lost and vulnerable amidst the open landscape of the college. And it is an inanimate statue, so not a robot, and clearly innocuous in terms of it can't act, it can't cause any physical harm. But, I mean, while it was obviously unable to move within the environment or interact with people, over 1,000 people petitioned to have it removed from the campus so that they don't have to confront him as they go about their daily lives. And you might be thinking that this is because it's a nearly naked man in the middle of a women's college. And when we looked at people's comments on this petition, you see, in fact, that yes, this was part of it, that people called it inappropriate, naked, offensive, as some of the top descriptors they used to report it. But a major component of their responses also referred to aspects of the Uncanny Valley, and in particular, people called it frightening and disgusting and disturbing. And these are really strong terms, and in particular, they indicate a substantial emotional negative response. And that implies that that people would be motivated to do something to regulate those feelings. And what I mean by that is that you can have a situation and it creates some emotional experience. And depending on what your goals are, say if you don't want to be unnerved, you can change aspects about the situation. So you can help reduce your stress. Say if you're giving a talk, you could run out the door and stop giving a talk in order to avoid the stressful situation. But that's not a very good idea because I have to give this talk. So instead, you could avert your attention. So for instance, instead of looking at everyone here, I could look at the floor or look at the ceiling. Again, not a great mechanism in this case. So alternatively, I can reappraise, think of everyone here in their underwear or something that's more comfortable. And this in turn all comes together to modulate the multi-system response, and with the goal being of reducing my stress levels. And so in this case with the Sleepwalker, that we wanted to understand whether or not people were, given how they were describing it, whether or not they were so motivated to do something about that, and in particular whether the statue's appearance really seemed to influence how they behaved around it. And in fact, people reported going so far as to take a different path through the campus to avoid him, or dressing him up, for instance, with a feather boa to make him less intimidating. And these are two examples of situation-targeted regulatory mechanisms. For instance, taking a different path is selecting to not be in that situation, and dressing him up is a way of changing the situation to make it less stressful. And these are two examples amongst many of ways people may deal with a significant emotional response. But given that we see that here with an inanimate statue, we wondered really what are the implications for human-robot interaction, where we have similarly human-like agents, but you add in the capacities to move and interact with people, and so you're adding in much more of a physical presence. So to investigate what exactly the implications are of an agent's anthropomorphic or human-like appearance for how and whether people may interact with robots, we conducted a within-subjects laboratory procedure where we were showing people pictures of humans and robots. And here we gave them the option to terminate what we call encounters, or the viewing of these pictures, by pressing a button. And what we measured then were people's explicit ratings of how the agents appeared, their press behavior, whether or not they were pressing a button, as well as their eye gaze. And this was to get at whether or not these human-like agents evoke regulatory mechanisms to help down-regulate their emotional experience to something less negative. And in particular, looking at the press behavior allows us to determine whether or not they're using situation-targeted strategies such as situation selection or modification, and the eye tracking allows us to look at whether they're averting their gaze in order to avoid the experience. So we have 4 conditions. We categorize the agents into a low, moderate, or high human similarity, so robot agents, and we also had a set of human images. And what we did is we started preceded each image with a fixation point of 3 seconds just to get them to look at the screen. Then we showed the images for a mandatory 6 seconds, and this is where we wanted to see, without giving them the ability to press a button, if they used gaze aversion to avoid the interaction. Then, after 6 seconds had elapsed, we gave them another optional 6 seconds of viewing time during which they could press a button. And this was to see, given the option to do so, do they attempt to change the situation or end the situation? And whether they ended it or not, we asked them for their reasons as to why, in order to distinguish between boredom versus actual discomfort, as well as interest versus just simple indifference in the laboratory task. And this was followed by the standard ratings that we use to evaluate these agents. And so what we saw here in terms of people's explicit ratings of the agent categories, for the highly human-like agents, we saw the highest ratings of eeriness. So this relates to how discomforting the agent might be. And this was significant relative to the category of low robot agents, moderate agents that had moderate human likeness or human similarity, as well as humans. And so we then proceeded to ask, like, are these human-like, these highly human-like robots so unnerving that they evoke these emotion regulatory mechanisms that seem to be evoked with the Sleepwalker statue? And specifically, just as a reminder, we were wondering if people engage in attentional deployment. That is, do they avert their gaze from the image during this period in which they cannot end the situation. And what we see is, yes, that with these highly human-like agents, that they fixate on the image less than any other agent category, the low agent robots with low human similarity, robots with moderate human similarity, and people. And then we moved on to ask, when we do give them the option to end the situation, do they do so? And what we saw is, in terms of pressing the button to end the situation early, end the viewing period early, that there was no significant differences between any of the agent categories, that people tended to press a button to end the viewing period for roughly 50% of the time. But when they did press the button and reported doing so for being discomforted, we saw that another indicator that people were discomforted by the highly human-like agents, seeing that they were more likely, when they pressed the button, to have done so because it was one of these highly human-like agents, and that was relative to all other agent categories. Whereas terminations caused by boredom, we saw for the highly human-like category that they did so for the least for these highly human-like agents. Again, relative to all other agent categories, or marginal for one of them. And when they didn't press the button, when they didn't press the button, they reported being motivated by interest, predominantly for the highly human-like categories, but this was only a marginal difference out of all of the robot categories. And this was higher than humans, but it didn't seem to stick out particularly to the highly human-like agents. And as far as indifference, that is, people viewing the images but not pressing the button, we saw they did so the least for, again, the highly human-like agent category relative to the other categories, but not a great difference between the set of robots. And so, in summary, what we have, or what we saw, is that relative to all other agent categories, these highly human-like or highly human-similar robots elicit greater eeriness. They elicit gaze aversion, that is, they fixated the least on agents that were high in human similarity, and they elicited greater discomfort, as evidenced by their reasons for pressing a button. We also saw that this elicited marginally greater interest in the images and reduced indifference, but the differences between the robot categories wasn't necessarily significant. And so what we can really conclude with is that we establish here that a robot's appearance influences whether a person is willing to interact with it. And that's particularly significant because we want to design robots for interactions with people. And so if we're designing them such that their appearance from the get-go causes people to run away, that's obviously not achieving our goals. And so with that, I will conclude and take questions.
We have time for maybe one or maybe two questions. If you could please introduce yourself. Yeah, and use the microphone in the middle.
Hi, strong microphone. Hi, Timothy Harrison. I'm from DSTL. Really interesting talk, and I'm interested in the area. It's really nice to see someone actually addressing this. What I was wondering was, in terms of the stimuli used, and so the robots you picked, you know, how did you pick them? And because there's the possibility of if you've got a kind of expectation thing of, oh, okay, so I'm picking robots that are close to humans, but what's your definition of that? And are there ones that you could design that would be creepy, or would there be industrial ones that would be
Yeah.
creepy, and you're kind of biasing it in that way. And have you thought about looking at a wider range, maybe? I don't know.
Yeah, so we had 15 instances of each category, and we selected them through pre-testing using standard indices of human similarity and eeriness. So it turned out with the ratings that the eeriness seemed to co-vary with human similarity. So that's a good question, and that's something obviously to explore further, because it's not quite clear whether it's due to the human similarity that the eeriness is as a result, or if that they were eerie from the get-go, and that's what causes all these other mechanisms. So there could be more industrial robots that are similarly eerie but not similarly human-like, but something to investigate.
Let's take one more quick question.
Okay, I have the same question, and the picture of each robot